Hey guys, in this question, suppose you need to know an equation for the tangent plane to a surface S at the point P equals 2, 1, 4. You don't have an equation for S, but you do know that the curves R1 of T and R2 of U both lie on S. They're asking us to find an equation of the tangent plane at point P. So, to start off, we need to find parameter values where the curves pass through point P. So point P equals 2, 1, 4. And that's from the question right over here. And we need to find parameter values. So to do so, we're going to take our first curve, so R1 of t, which equals 2 plus 2t plus, 1 minus t squared, 4 minus 5t plus t squared. And I'm going to take the simplest component to deal with because I'm going to be solving for t. So that is the x component. So I'm going to do 2 plus 2t. I'm going to set this equal to the x value on point P, which is 2. So equals 2. Use this color. 2. And solving for t, I'm going to get t equals 0. Okay, now we're going to do the same thing, but for R2 of U. So for R2 of U, we have R2 of U equals 1 plus U squared, 2U cubed minus 1, 2U plus 2. And then again, I'm going to determine which one's the easiest to deal with, and that's the Z component for this one. So I'm going to do 2U plus 2. I'm going to set this equal to the Z component of my point P. So this is 4. And then if I solve, I'm going to get TU equals 1. Okay, now that I have my two parameters, so t equals 0 and u equals 1, I'm going to go ahead and get my tangent vectors at point P. To get my tangent vectors, so let me write that down. So tangent vectors at P. I'm going to be taking the derivative of R1 of t, and I'm also going to be taking the derivative of R2 prime of u. So let's get started. So for the derivative of R1 of t, and I'm going to be referring to this one, it's going to be 2, negative 2t, negative 5 plus 2t. And then for R2 prime of u, I'm going to be referring to this again. So 2u, 6u squared, 2. Okay. Now that we have our tangent vectors, we need to get it at P. To get it at P, we're going to be using our parameters. So we're going to be plugging in 1 for t, or 0 for t, and then 1 for u. So we're going to have 2, use a different color. So we have 2, negative 2 times 0 from here, negative 5 plus 2 times 0 again. And we're going to get 2, 0, negative 5. And then for R2 prime of u, it's going to be 2 times 1 from over here, from our parameter. Then 6 times 1 squared, 2. So this is going to be 2, 6, 2. Okay. And now I can take the cross product from the normal vectors we just calculated or obtained. So over here and over here. So I'm going to label the resultant of the cross product with the v equals. First row, I'm going to have I, j, k. In the second row, I'm going to have my first normal vector of 2, 0, negative 5. And in the third row, I'm going to have my second normal vector of 2, 6, and 2. Taking the determinant of this, I'm going to get I times 0 times 2 minus negative 5 times 6. That gives me 30 minus j, and then it's going to be 2 times 2 minus negative 5 times 2. That's going to give me negative 14, or positive 14, sorry. Positive 14. And then plus k, which is going to be 2 times 6 minus 0 times 2, which is 12. So I can simplify this to give me 30i minus 14j plus 12k. Or I could write this as 30, comma, negative 14, comma, 12. But I can also get the normal vector in simplified form. So I can see that they all have a GCF of 2. So I'm going to take a 2 out. I'm going to write it as 2 times 15, comma, negative 7, comma, 6. So equation of a tangent plane through a point P equals 2, comma, 1, comma, 4. I'm going to have to plug this into my tangent equation formula. So it's going to be 15 from over here, 15 times my x value minus my initial x, which is 2. So 2 plus my y value, which is negative 7. So I don't really need the plus sign here. So negative 7 times y minus my initial y value, which is 1. And then plus 6 times z minus 4 from up here. And then this entire thing equals 0. And if I want to simplify this, I can write it as, if I distribute all these over and then simplify, combine like terms and simplify, I'm going to get 15x minus 7y plus 6z minus 47 equals 0. So that's your answer.